Hi everyone, and now we're going to talk about our new topic. After the Zalman's framework of problem solving, now we are going to deal with the Polya's problem solving framework. And well, of course, one of the major problems of you as a student in mathematics is on how to solve word problems. And sometimes you have difficulty understanding and grasping the main idea of the problem and how to deal with it and to solve for it. So it's very important that there is always a clear understanding on how to solve problems, most especially in the mathematics as a course. And don't you worry, here in the Polya's 4 steps in solving problem, we will be learning on how to solve the mathematical problem in a different way. So let's hear. For our first part of our discussion, let's get to know who is the major contributor of this framework in problem solving. Well, of course, it came from Mr. George Polya. George Polya is one of the foremost recent mathematicians to make a study of problem solving, and he was born in Hungary and moved to the United States in 1940. And he is also known as the father of problem solving. So I would like you to remember always who is the father of problem solving, and that is George Polya. And his major contribution is, of course, for his work in problem solving. And growing up, he was very frustrated with the practice of having to regularly memorize information, and he was an excellent as a problem solver. So in 1945, George Polya published the book How to Solve It, which quickly became his most prized publication. It sold over 1 million copies and has been translated into 17 languages. In this book, he identifies 4 basic principles of problem solving. So let's see what are those. These are the 4 basic principles of problem solving. First is Polya's first principle is to understand the problem. Second, devise a plan to solve the problem. Third is to carry out the plan. And the fourth is to look back or revise or check on it if the solved answer is correct. Now let's talk about the first principle of Polya's problem-solving framework. First is to understand the problem. And this part of Polya's 4-step strategy is often overlooked. You must have a clear understanding of the problem. So to help you focus in understanding the problem, consider the following questions. And these are some questions that you may be asked to yourself before you solve the problem. So Polya taught teachers to ask students questions such as, do you understand all the words used in stating the problem? Or what are you asked to find or show? Or what is being asked? So can you restate the problem in your own words to make sure that you understand the problem very well? So it's very important that you can just restate what that the problem is asking for. And can you think of a picture or diagram that might help you understand the problem? Or any pattern of how you'll be able to solve the problem? So is there any enough information to enable you to find a solution? So once you think of any plan or any instance that You have the rule and principle of finding the answer for the problem. But is that enough? No. And after that, well, going to proceed to the second principle. Once this questions has been answered already, let's see the second principle, which is devise a plan. And sometimes it is necessary for us to be able to understand or to solve a problem in mathematics. We need to devise a plan. Just like an engineer, that before you construct a certain innovative materials, or for specifically for civil engineers, before they construct a building, he or she needs to do a floor plan for a building that he wants to build. And to be able to succeed to solve a problem, he could use different techniques or way in order to get a positive result. Here are some techniques that could be used, and you could one of these or combination to be able to solve the problem. The skill of choosing an appropriate strategy is best learned by solving many problems. You will find choosing a strategy increasingly easy. A partial list of strategies is included. So you may use either of these given strategies: the guess and check, look for a pattern and make an orderly list, or draw a picture, use a model or a diagram at least, work backwards, it works as well, eliminate possibilities, consider special cases, or use direct reasoning. With the use of this kind of strategies, then you can be able to have or to devise a plan before you can proceed to performing or solving for the problem itself. And that what we're going to discuss for our third principle. The third principle of Polya's problem-solving framework is carry out a plan. And after we devise a plan, of course the next question is, how are you going to carry out the plan that you made? And now to be able to carry out a plan, this step is usually easier than devising the plan. In general, all you need to do is care and patience, given that you have the necessary skills. Why do I say that it's usually easier than devising the plan? Because we all know that when we are performing or solving for a problem in mathematics, once we got the question, once we read the problem, we can be able to at least synthesize in our mind how we're going to solve for it. And that's why it's really easy than devising a plan first. And persist with the plan that you have chosen. If it continues not to work, discard it and choose another. So you can go back to devising the plan and choose from those strategies that you can apply with so that it will work. And don't be misled. This is how mathematics is done, even by professionals or even by us, your teachers. Now we're going to see and move forward for the last principle, or the fourth principle of Polya's problem solving framework. And that's what we call look back. Look back or check like that. Just like on what you do in solving worded problems in algebra or geometry, probability, statistics, you should always check if your answer is correct or not. So you need to review the solution that you have made. And how will you check for the solution? The following could be your guide, like make sure that your solution is very accurate and it jives with all important details of the problem. Or interpret the solution in the context of the problem. Or try to ask yourself that the solutions you've made could be used in other problems. Polya mentions that much can be gained by taking the time to reflect and look back at what you have done, what worked and what didn't. So doing this will enable you to predict what strategy to use to solve future problems. That's really nice though. When we are taking this kind of step or this fourth principle of Polya's problem solving framework, it really helps for us to be able to remember the steps that we made on how we perform to solve the problem. And when we encounter same kind of problem in the future, it will be easier for us because we take this kind or this fourth step or fourth principle of Polya's problem solving framework. So after we discuss all of those principles of Polya's problem solving, the first is to understand the problem. Second is to devise a plan. Third is to carry out a plan or solve for it. Fourth is to look back or check on it. And now we are going to apply what we have learned from those principles. And let's move forward to the part 2 of our discussion. By discussing these illustrative examples. Example number 1, we have the problem. Twice the difference of a number and 1 is 4 more than that number. So find the number. First step, of course, to understand the problem, make sure that you read the question carefully several times. Since we are looking for a number, we will let x will be a number, or x will be the number. And for the step 2, or for the second principle, devise a plan, is for the translation of those verbal phrases in the problem to mathematical equation. So twice the difference of a number and 1 is 4 more than that number. That's why when we translate it into equation, is 2 the quantity times the quantity x minus 1 is equals to x plus 4. And probably by seeing on it, the final or x will be 6, or answer will be 6. But let us see if that will jive in our problem by carrying out our plan or to solve for it. So we have 2 times the quantity x minus 1 is equals to x plus 4. So we distribute 2 to our x plus 1. So 2 times x is 2x. 2 times negative 1 is negative 2. Is equals to x plus 4. And then we'll just have to subtract x from both sides of the equation. We have 2x minus 2 minus x is equals to x plus 4 minus x. So right now we have x minus 2 is equals to 4 by combining like terms and as we perform the given equation. The next step we need to do is, of course, to solve for the value of x. First option, we can add 2 to both of the equation in order for us to eliminate negative 2 on the x minus 2. That's why we have x minus 2 plus 2 is equals to 4 plus 2. Or you can also just transpose this negative 2 to the right side of the equation. It will be equals to, or it will be x is equals to 4 plus 2. And 4 plus 2 is equals to 6. That's why we have x is equals to 6. And now for our fourth principle of Polya's problem-solving framework, if you take twice the difference of 6 and 1, that is the same as 4 more than 6. So this does check, and our final answer will be number 6. Let's see the second example. One number is 3 less than another number. If the sum of two numbers is 177, find each number. Now let's apply the four principles of Polya's problem-solving framework. First, we need to understand the problem. Make sure that you read the question carefully several times. So we are looking for two numbers, and since we can write the one number in terms of another number, then we can let x as the so-called another number. And one number is 3 less than another number. That's why we have x minus 3 will be the so-called one number. And in devising the plan for our second principle, we need to translate those verbal phrases from the problem into mathematical equation. So the sum of the two numbers is 177. From the understanding the problem that we have x and then x minus 3, we'll just get the sum of it, and then it will be equal to 177 according to our problem. So the quantity x minus 3 plus x is equals to 177. Alright, so let's see the third principle. So we're going to solve for it, or we're going to carry out the plan. And our equation is x minus 3 plus x is equals to 177. So just add those two x's. We have 2x minus 3 is equals to 177. And then next step that we need to do is to make sure that those terms that has a variable x is on the left side. So we have two options in order to do that. First is you can add 3 to both sides of the equation to eliminate negative 3 on the left side. Just like this, 2x minus 3 plus 3 is equals to 177 plus 3. Or the second option is you can proceed to the transposition method. So you can just transpose negative 3 to the right side of the equation, and it will look as 2x is equals to 177 plus 3. And 177 plus 3 is equals to 180. That's why we have 2x is equals to 180. And to get the value of x, just divide both sides of the equation by the constant 2. And x will be 180 divided by 2 is equals to 90. So our x will be 90. And for the step 4, to look back or check and interpret, if we add 90 and 87, a number less than 90, we do get 177. So if you just apply the answer that we got from the given problem, it will jive on that statement. So the final answer, the one number is 90 and the another number is 87. Okay. Alright, now we'll discuss the third example. It's very easy. Find 45% of 125. Step 1, or the first principle, we need to understand the problem. Make sure that you read the question carefully several times. We are looking for a number that is 45% of 125. So we will let x be the value that we are looking for. And to devise a plan for our second principle, we need to translate the given statement, a number that is 45% of 125. The translation of that will be x is equals to 0.45, the decimal form of 45%, times 125. And for our step 3, so just carry out the plan or to solve for it. So just solve 0.45 times 125, and the answer will be 56.25. So our x will be 56.25. In our step 4, when you look back or check and interpret, 56.25 is 45% of 125. So it satisfies or it jive on the given statement on our problem. So the final answer, the number is 56.25. That's how easy. Now for the part 3 of our discussion, of course, we can be able to evaluate if you learn something from this topic, if you can apply those principles by answering different problems. And I have prepared here 5 different problems. Don't you worry, cause I will include a specific form to our Google Classroom, and you can be able to see these problems. Let's move forward to the instruction. So first, you need to create only one document for your answers in the 5-item quiz. And those quizzes, each of those will have 8 points. So you can gather a maximum of 8 points for each of the item. And you may attach a photo, but make sure that the image is not blurred. Of course, when you are going to solve for it, you can just write down your answer and then take a picture of it and insert an image to the file. Or able to make sure that you have less than amount of the file size, you can just type your answer on the given document or the Word file, and make sure that you will going to save it in PDF format, and the maximum file size is 1 gigabytes. Name your file as provide your section or your block, then your last name, and then your first name. Alright, so just take a look on the Google Classroom for further instruction. So that will be all. Thank you so much. I hope you learned for today. Thank you. Bye-bye.